Alright, and we're back for one last quick video. This first example is actually, I have it completely worked out for you already, and I just want to walk through it because it's what we've already been doing. It's just now a matter of not writing it as a function, but writing it with y and x, so that way it's easier to graph. But if Ted weighs 210 pounds and he's trying to lose weight, he believes that if he exercises and eats right, he will lose 5 pounds per month. Again, X is the number of months because it's 5 pounds per month, and then Y is Ted's weight after X months. So in the past we would have said maybe W of X equals 210 minus 5X. Well, now we'll just say Y equals 210 minus 5X. That's something that will make it easier for us to graph and look at ordered pairs. Okay. In the past I would have asked you if his goal weight was 185 pounds, how long would it take to reach his goal? And we would have said, well, we don't know what X is, how many months, but we do know what F of X or W of X is. It's 185 pounds. We would have put a 185 in for W. Same idea, except instead of W of X, we're calling it Y. So just kind of write that down. We used to do this, and now we're doing Y equals. Same idea. And so we say X is equal to 5 when W of X is 185, or he's going to reach 185 pounds in 5 weeks. All of this is the same, it's just a different format. So be confident because you guys rocked this stuff, and so you guys know what you're doing. Now, there are a couple of different ways of looking at it, though. What if I just give you a table of values and I want you to define variables and find rate of change and elevation at the start and all of that? This is where you got to be a little bit careful. Now with the variables should be pretty quick and easy. X is still going to be our input, or in this case, my X is the number of steps. Use the table to help define your variables. And then this was, or used to be, my E of X, but now we're going to call it Y. So I'm going to define Y as my elevation. Anybody else thinking of U2 right now? Or is it just me? Yeah, I'm old. Okay, sorry. Okay, elevation in feet. Now, finding my rate of change. I need to find, whoa, that blew up pretty quick. I need to find my change in Y. I'm going to look at all of these, what I call jumps. Okay, if I jump from 500 to 480, that's gone down 20. 480 to 460, that's gone down 20. 460 to 480, that's gone down 20. So my change in Y is a negative 20 feet. My change in X, all of these jumps, 10 to 20, that's gone up 10, that's gone up 10, and this has gone up 10. So my change in X is 10 steps. My rate of change, or my slope, is negative 20 feet for every 10 steps. When I simplify that, it's, and I'll do red because that's what I was using before, negative 2 feet per 1 step. If there are labels and units, use them, please. At least when you're defining it. Probably not as much in your equation. But now this one's a little bit trickier, and we've seen this, but I don't know where I start. Because technically our starting point is always when we have 0 for my X and whatever that number is for my Y. I don't have 0 for my X. But I have a pattern, and I can work my way backwards. 40 to 30 to 20 to 10. If I go back 1 step, and I'll just make it a big leap up to here, to 0, well, I just took away 10. That was just working my pattern backwards. Now, instead of plus 10 to go backwards, I had to minus 10. So instead of minus 20 to go backwards 1 step, I have to add 20. This should be at 520. That's going to be my starting point at 520 feet of elevation, or at 0, positive 520. I have everything I need now. My rate, or my slope, and my y-intercept. I can write my function, or my equation. Y is equal to negative 2x plus 520. Just make sure if you work backwards, if you have to jump 2 back, you're using the opposite operation, and you do the opposite operation here and jump 2 back here. And then last problem of the notes, I promise. Whoop. The temperature at the start of your day was 56 degrees. 6 hours later, it was 64 degrees. We've talked about this before as well. Writing two ordered pairs. Time should be my input, or number of hours, and in this case, temp is going to be my output. So if I kind of write it out this way, that helps me write my two ordered pairs. The first one's the trickiest one. The temperature at the start of your day was 56 degrees, so the temperature was 56 degrees. The temperature 6 hours later was 64 degrees. But what goes in for my input? Well, the only thing that truly matters is that this one is 6 hours past this one. So if I put 1 in here, I can't put 6 here. I have to put 7. That's okay. I can do that. But the easiest way to do this, especially on problems that they're asking me to write an equation, I know that if I'm writing an equation, I need a slope and I need a y-intercept. And if I have a y-intercept, then I have an x-coordinate that's 0. So make that one 0. That's going to make your life a lot easier later on. And if that's 0, this one is 6 hours later, so that's 6. Okay, if you make that 1, it makes this part really much more work. Okay, so just be careful and make your life easier if you can look ahead and see that. Okay. Now, I know that my y-intercept is at 0.56. I can go ahead and start my function rule. My y is going to be equal to whatever I get my slope to be, or my rate of change to be, x plus 56. I just got to figure out my rate of change now. And if I use my slope equation, I'm going to set my table, subtract my y-coordinates, 64 minus 56, subtract my x-coordinates, 6 minus 0. Okay, this is going to get me my slope, or my rate of change. That's 8 degrees over 6. We're dealing with hours. We simplify that. 4 degrees over 3 hours. I don't include the labels when I come down here. My slope is 4/3. I have y equals 4/3 x plus 56. Alright, ladies and gentlemen, that is the last one for the day. We are going to practice some graphing, and then you've got a homework assignment. And good luck!